here, back with another video. And in this video, we're going to talk about between subjects designs and how they're different from within subjects designs. And we'll also touch upon mixed designs. But just for a quick little recap, between subjects designs is basically you have participants that serve in different conditions, more than one condition. Within subjects design, you have participants serve in the same condition, and mixed subjects designs are a combination of both, between and within. So what are some characteristics and some advantages of between subjects designs? Well, the best thing about between subjects designs is since you have participants in different conditions, you can isolate the treatment effect. So you can be sure that whatever you expose your participants to, that it is causing the change in the dependent variable. Because remember, you manipulate the independent variable to see if there's an effect on the dependent variable. You also eliminate carryover effects. So carryover effects occur when you have a within subjects design and participants serve in multiple conditions. And you can actually eliminate this by having participants in different conditions. The most simplest example of a between subjects design is when you could use an independent sample t-test. And this is when you have one independent variable with two levels. And one example of this is maybe you show your participants in one condition a video related to telling them to attend to some colors, maybe certain colors you pick, and then you have a control group where they don't see this video. And basically one group is primed, the other group is not primed, and you can assess, right, how the independent variable affected the dependent variable. Maybe you give them some measure of attentiveness. So basically what you have here is there are two levels of one independent variable, and to analyze that you would use a t-test. Now researchers can do what we call a manipulation check, and this allows them to know whether the manipulation was noticed. Basically, if the participants paid attention to the stimulus in the condition. Now the control group is there because these participants did not receive the intervention or treatment. And you'll hear the term experimental control, and that refers to the steps researchers take to reduce the threats to internal validity. Now the issue with some between subjects designs, and there's some ones you want to consider, is that you need, as you get more complex in your designs, you're going to need more and more participants in each condition. Generally speaking, you want about 30 participants in a condition. So if you have just two conditions, you need 60 participants. But then if you have 4 conditions or 8 conditions, you could see how quickly the number of participants would add up. And this is so you can get the adequate power you need to detect differences between groups. And you can actually do a power analysis before you conduct your study. And I would suggest you do that. That way to make sure that you have an adequate sample size. Because generally speaking, the larger the sample, the greater the power you have to detect differences. Now, as I was just saying, we could calculate power, and there are different routes you could do. G-power is a very common approach to conducting power, and this is actually a free online software that calculates power for you for a given design. So what is the importance of our power analysis? As I was just saying, it gives you some degree over control over the type 2 error. So generally speaking, the more participants you have, you decrease the likelihood of making a type 2 error. Now, as you get into more complex designs, you can have designs with more than one independent variable. And if you have more than one independent variable, you have to start thinking about interactions. And basically, an interaction is when the effect of one independent variable is not the same for all the levels of the second independent variable. Now, I'm not going to go over evaluating simple effects and interaction effects by hand because statistical software can do it for you. If you're using SPSS or Jamovi or JASP or any one of these programs, they could do it for you. However, we could talk conceptually about what you have to do when you move beyond two independent variables. So randomized groups designs, all that means is you're randomly assigning participants to groups, meaning they have an equal probability of being in X amount of groups that you have. So if you only have two groups, they have an equal chance of being in group 1 or group 2. And our simplest one is if you have one independent variable, or factor as we call it, with two levels, you would just do an independent sample t-test. This is the most basic type of analysis you could do. However, you can expand the number of independent variables you have. And a word of caution, don't do multiple t-tests if you're expanding the number of independent variables. That'll increase the probability of making a type 2 error, so we want to avoid that. Now, if you do expand, and let's say you have more than one independent variable, and you have a dependent variable, we could use a one-way ANOVA. We call that analysis of variance. And we use an ANOVA when you have 3 or more groups. We could also get into two-factor designs. And a factorial design occurs when there is more than one independent variable. Well, basically you're having maybe two independent variables and maybe each of them have two levels. So you're introducing interaction effects. Now, the good news about two-factor designs is they give you more information as a researcher about the variables of interest. You can ask more complex questions, and you can see if these variables interact on some level. Now, the disadvantage of two-factor designs is it requires more participants than a one-factor design because you're introducing more conditions or more levels. And they're usually more challenging to conduct because you're juggling more people and getting more participants. A fully cross design is a research design when all possible combinations of the levels of the independent variables are representative. Now, there are some nomenclature you should know. So if you have a 3x2 ANOVA, that means you have one independent variable with 3 levels, and you have another independent variable with 2 levels. So keep that in mind as you read through the nomenclature. Now, a little bit different than randomized designs is you could have a match pair design, and basically all that means is instead of just randomly assigning participants to groups, you are matching them on some key characteristic that may affect the independent variable. How can we reduce error that creeps into our study? Because all studies have an error in it. Well, one thing we could do is use random assignment. Now, random assignment washes out group differences, so that helps. And we can also make sure that we pick good measures. I think it's very important that when we think about the study we do, that we pick valid and reliable measures. Because what happens is if you have a lack of reliability, then you get a lot of error creeping into your study. So we want to be very careful about that. We also want to standardize directions and make sure everybody gets the same directions in each condition. And so you want to treat everybody the same. You want to act the same as a researcher. So we want to reduce as much variability as possible in our studies. Now, if you want to get to even more complex designs, you can have something called a Manova, or a multivariate analysis of variance. And basically, what this is different between an ANOVA and a Manova is an ANOVA has one dependent variable, where a Manova has multiple dependent variables. Thanks for watching, and I'll see you in the next video. Take care. Bye-bye.